We're going to explain how we can simulate a logic function using Logisim. The logic function we'll use as an example if is the expression f is equal to not a and b or not c and d. There's another way that we can write this expression, and this method explicitly lists the inputs or the variables for the inputs, which are in this case a, b, c, and d. And the expression is not a and b or not c and d. This time, to denote the NOT gate or the inverter, we put a bar on top of the variable. Note that both expressions are equivalent and we can write them either way. So before we connect this expression in Logisim, let's create a truth table or a template for our truth table for that expression. We have a total of 4 inputs, so that means we'll have 2 to the 4, which is equal to 16 different input combinations. So let's insert a table with 16 different rows and 4 variables for the inputs. But since we need to also express the output in a different column, I'm going to add 1 additional column. And for the number of rows, I'm going to add 1 extra row so that I can label each of my variables. So I'll have 17 rows and 5 columns. The first row will be, the first column will be for variable A, and then B, C, and D. The last row will have the value of the output. Maybe to help me, I can just highlight the row of the output as such, so it is clear that this is an output, and you can even highlight these as well. I do not know the values of the output yet, but I can tell the possible combinations for the inputs, starting from where the case where all the inputs are 0, ending with the case where all the inputs are 1, because each input can have a value of 0 or 1, or low or high. An easy way to express this is to fill the template for the truth table here is to vary the value of variable d in each row. So the first row will be 0, then 1, 0, and then 1, 0, 1, and so on. Since excuse me, since there's a pattern here, I'm gonna copy and paste until I fill in the table. So here it will be 0, 1, 0, 1. The second column from the right will stay 0 twice, and then it will change to 1s twice as well. There is another pattern here that will generate, so I'm going to copy and paste until I fill in the table. So 0, 1, 0, 1, 0, 1 for the first column, 2 zeros, 2 1s, 2 zeros, 2 1s for the second column. Here I will also multiply by 2, so it will be 4 zeros and 4 1s. I'll copy that. The last column, or the first column from the left, will have 8 zeros and 8 1s. I know that the column A has to have 8 zeros and 8 1s because there's 16 possible combinations. So half of them could be 0, half of them could be 1. Now I have a template table for any 4-input combinational circuit, except of course I might have to change the name of the variables depending on the expression. Okay, I will attempt to fill in the values of the output based on the simulation results that I will get from Logisim. So let's go back to Logisim and try to connect the expression. I have 4 inputs, A, B, C, and D. So for those, I'm going to place the input pin. If you ever forget, you can click on the pin and check where it says output question mark. No, this is not an output pin, then it has to be an input pin. All right. This one is going to be my A. I'm gonna place another input pin and label it B. Input C, and finally the last input is D. Okay, I'm gonna place my output pin as well, which is the round pin. Again, you can check where it says output question mark. Yes, this is an output. You can vary it if you want from here, but it's easier to place one from scratch. So this is an output pin and it is labeled as F. I've placed all the inputs and the output pins that I need. Now I will start placing gates. I know A is complemented, so for this I'm going to place a NOT gate from the bar here. This is the NOT gate. A is inverted, so this is A. The output here is actually not A. Just to help me, I'm going to label it from the bar here. I'm going to type A bar, just to help me understand this further, that the input to this NOT gate is A, the output from it is actually not A, or A bar. Alright, B is as it is, it's not complemented, however it is ANDed with not A. So I will need an AND gate. I'll have to make sure that it's a 2-input AND gate, so I will click on it, change the number of inputs to just 2. I'll have 2 input AND gates. See this blue dot? This is where I will have to connect wires. Okay, this is the first input to this AND gate. The second input is B. Okay, again, if you prefer to, you can label this wire as not A ANDed with B. Okay, now I will need one more AND gate that will take not C ANDed with D. So I will place an AND gate, change the number of inputs to 2. I don't have not C, or the complement of C, but I have C. All I need now is just an inverter gate, or a NOT gate, that will invert C such that I will get not C. Let me label it again. This is not C. Okay, now I will simply connect not C to this AND gate. The second input to this AND gate is D. Notice that the AND gate now has a higher priority compared to the OR gate at the end, which is why I waited till the end to place the OR gate. I will need a 2-input OR gate. The first input is going to be the output of this AND. Okay, the second input is going to be the output of the second AND, which is this. Finally, the output of the OR is the output of the expression, which is F. If you prefer to, again, feel free to label this as not C ANDed with D. Not C ANDed with D. The final output is F, which is equal to not A and B, or not C and D. Notice that here I'm paying attention to the priority of the logic operators. The AND has the highest, or actually the NOT, because it is on a variable, so the NOT gate has the highest priority, then the AND gate, and finally the OR gate in this case. So wherever I see a NOT gate, I have to implement it first, and then I will do the ANDing and finally the ORing in this case. Okay, now I have the complete expression. To simulate it, I will click on the hand to be able to control the inputs. But make sure that simulation is enabled by going to simulate, simulation enabled. By default, it should be enabled, but just in case you accidentally turn it off, that's how we can enable it again. Okay, so make sure simulation is enabled, click on the hand, and then you will be able to control the value of the inputs by simply clicking on them. The output, I cannot change it, or I cannot control it manually like this, but rather it will be driven by the circuit. I will read the output and enter the inputs. So starting from the first row in my truth table where all the inputs are 0, F is also 0. So I'm going to record 0 here in the first row. Let me look at the second row here. In the second row, only input D is 1, all other inputs are 0. So I'm going to change it in the circuit. D is 1, all other inputs are 0. The output F happened to be 1, so I'm going to record 1. In row number 3, which is the third possible combination, input C is 1, all other inputs are 0. So C is 1, everything else is 0. F is 0, I will record 0 for F. In this row, C, D are 1, everything else is 0. C, D are 1, everything else is 0. The output is 0. Here, A is 0, B is the only variable that is a 1. So B is 1, everything else is 0. B is 1, everything else is 0. The output is 1. So I will record 1. Now B and D are 1. B and D are 1. So B and D are 1. The output F is also 1. Let's try the last row, for example, where all the inputs are 1. The last row where all the inputs are 1, the output is 0. So we'll repeat until we complete the table. Just pay attention to the variable name as you go, because here they're A, B, C, D, and here from the top it's A, B, C, D. Sometimes A is not necessarily at the top in some cases, so just pay attention to the name of the variables before changing the values. So now B and C are 1, everything else is 0. The output is also 1. I'll keep it as 1. Here only A is 0. When only A is 0, the output is 1. When only A is 1, like this, the output is 0. Now A is 1, D is 1. The output is 1. Here A is 1, C is 1. A and C are 1. The output is also 0, 0. Now A is 1, C, so all inputs are 1 except for B. The output is 0. Now A, B are 1, everything else is 0. The output is 0. There is 2 more left. Now in this case, C is the only variable that's a 0. The output happened to be 1. Here only D is 0. So like this, and the output F is 0. Now we have the complete truth table and the complete expression. We can screenshot it, for example, or before we screenshot it, let's add a text with my name just to sign my work, and then flag from the keyboard Shift and S to take a screenshot like this. I'm gonna paste it right below the truth table. So now we have both the truth table and the logic function. By the way, if you need to zoom out in Logisim, of course, you can just click on the arrow, the top or the down arrow if needed. Okay.